Hello, everybody, and welcome to today's very special edition of the Scaleway sessions. I am your sometimes and forever host, Dan. I'm the head of developer relations here at Scaleway. I am joined, as almost always, frequently, sometimes, many times, by Eli, one of our partners in crime here on the developer relations team. And our special guest today is Thibault. Thibault, why don't you introduce yourself
Nope.
today?
Outside.
Good afternoon, Dan. Hi, everybody. I'm Thibault. I'm working at Padok as a head of security. Um, I did some pen testing for 5 years, um, all kinds of different systems, banks, websites, mobile apps. And after some time, I get bored of Windows, so I decided to move on to Kubernetes and cloud environments. And so it's been 2 years. I'm trying to defend and attack cloud infrastructure, mainly having Kubernetes cluster on it, of course.
Excellent, fantastic, and that's actually an excellent segue into our topic today. Today is one of our many on a long-running series where we get to call Dr. Kube, the show where we get specialists in Kubernetes onto our show and we ask them ridiculous questions. So Thibault has bravely offered to be Dr. Kube on today's episode, and as always, we have collected questions from you, the audience, the community, from Slack, from forums, from Reddit, from Stack Overflow, from all the different places where we like to hang out, we like to interact. We've collected those questions, and we've shared a couple with them with Thibault ahead of time. Right, he's not walking directly into the unknown. We don't like that so much. But as always, if you have questions, if you didn't have a chance to interact with us the first time around, you're watching the show now, there's a million ways to get a hold of us. Scaleway_devs on Twitter or X or whatever it's called now. It's fine. Hit me up on Mastodon. Also, the Scaleway Slack. Definitely hit us up there. And any other Slacks we happen to share that Eli happens to be on, that I happen to be on, that Thibault happens to be on, just send him all the questions. Don't worry about it. Tell him Dan gave you permission. It's fine. Okay. And we'll see if we can get to them on the show. So, in the past, when we've done Call Dr. Kube sessions, that's been pretty open-ended, where just like, I don't know, Kubernetes. And then we just started talking about Kubernetes. And some of the feedback that we got from you, the community, was that it's such a huge topic that there's just so much space to cover that every episode, whilst interesting, lacked direction, right? You didn't know what you were going to get when you called Dr. Kube. Right? It was going to be Kubernetes, but what? So this is not the first time we try this. We're trying this. You know what? Let's just focus on a theme, on an area, on a topic, on an aspect of either using Kubernetes or being part of the ecosystem. And for this edition, we're going to be focusing on, drumroll please, you might have guessed it, security concerns. Right? And Thibault again has graciously offered to lend his expertise.
And before we go any further, I would like to make sure Thibault gets a chance to show off he's playing the part beautifully with a stethoscope and a lab coat. Yes.
Excellent. Well, yeah, when the Dr. Cubes are really, going whole hog into it, right? I mean, a little bit of cosplay, everybody enjoys that. Speaking of a little bit of cosplay, going to go see the Barbie movie this weekend. I know for all of you out there who are like, Dan, how come you haven't seen it 7 times yet? That's out of character for you.
Life's
yes.
been busy.
But I've been waiting to see it this weekend. I've got a friend coming in. We're dressing up. I'm going Ken. They're going Barbie. It's a whole thing. Going to be super, super fun. So any excuse to dress up in costume, be it on live stream, be it to go to a movie theater, let's take it. Let's take it where we can get it, everyone. Okay. Thibault, are you ready to assume the mantle? Very good.
Yes,
so we have a list of questions that some of them we shared with you ahead of time. Is there anything in particular there that you'd like to start with, or should we kind of just wade into the space?
Yeah, I think it was a good introduction, saying that Kubernetes is a wide world and you have so many things to think about when you talk about Kubernetes. It's like an operating system in itself, so it's especially difficult to secure too. You have to think of a lot of things. So I just think it was a good introduction, but you can go ahead with the questions.
All right. So Eli.
All right, I have the questions up here.
Mhm.
So this is actually one from me, because I am so curious about this. It's one of the things I've talked about every time we've talked about Kubernetes. I'm like, that's a lot of attack surface. So the question for me is, where do you think the lowest hanging fruit, or like really easily won security gains, are in a Kubernetes deployment? And are there specific kinds of deployments where that'll vary?
Um, it's a good question because you have lots of different things you can do to secure a Kubernetes cluster. Maybe I will get back to the attack surface just after, because it's also a very interesting point. First thing to consider is, of course, role-based access control, RBAC. I see many companies where, for simplicity, they give full admin access to developers, and it happens more than you can think. So I think it will be the first step. Just give low privilege role for developers, giving the minimum privileges they need to have to be able to work properly. It's a general security principle, of course. About airbag, we did some interesting stuff for administrators. When you are an admin, you don't always want admin rights. Sometimes you can make a mistake. We have some companies who, by mistake, they put the whole API servers anonymously reachable. So they had a major security breach because of that. So we developed a small alias like sudo. It was just kudo. So you have normal rights, and when you need to access privilege access, you assume a service account in Kubernetes, and you can get admin easily.
Hmm.
It was just a small digression, but I think that's interesting.
Yeah, I mean, explicit is always better than implicit, right? If the thing that you're accessing is dangerous, you want people who are accessing it to be very conscious
Aware.
of that. Yeah.
Yeah, exactly.
Yeah.
The other another mechanism that's native from Kubernetes is the namespace. Namespace are very easy to implement. It's kind of segregation between pods. It's super easy to set up, and it's a good habit whenever you install something new to create a dedicated namespace for it. It won't break anything normally. Uh,
What are the cases where it could break something? Are they very rare, or is it sort of how much do you have to be aware of those cases when you're creating a new namespace?
it's only if the thing you are deploying needs to access some assets in other namespaces. So I don't know, for example, a secret manager, or um, I don't even have a simple example, so it doesn't happen a
Is that
lot.
right? I'm assuming in that case the failure mode would not be that you've introduced a security gap, but more that the new thing you're installing won't work properly.
Yes,
Yeah.
exactly.
So it's a less bad way to fail by assuming that you should just create a new namespace.
Yes.
Hmm.
Most of the time you have admin components who are handling secrets, DNS, and they have very large privileges, or you have simple application who just need to run in Kubernetes, and they don't need to go to access other namespace normally.
Hmm.
Um, After you set up airbag and namespace, if you still want to work on privileges, a very good thing to do is to prevent dangerous behavior with policy engines like Kyverno. I don't know if you know Kyverno.
I've heard of
Um,
it, but not an expert by any means.
it's a CNCF tool, open source, and you can create simple policies as YAML. It's very easy to write, and you can prevent, for example, the deployment of a privileged container. So a privileged container is one of the most dangerous things you can do in Kubernetes. You have a developer, he's able to deploy pods. If you don't have this kind of policy preventing him for deploying a privileged container, he could easily escalate his privilege from a pod he deploys to the node. And when you access a node, it's basically game over because you will access other pods.
Right.
And
You're in the network now. Yeah.
yes, so Kyverno, or there is also gatekeeper, but I think it's more complicated to use. It can be simple tools with predefined policies you can use to help you prevent dangerous behavior in Kubernetes. So that could be a cool thing. Maybe it's not a low-hanging fruit, but I wanted to talk about Argo CD because it's making a lot of noise. It's a way to automatically deploy assets whenever a developer is pushing code on Git, basically. And I think it's a very good security measure because before this kind of systems, developer had, through the CI/CD, access to the Kubernetes cluster. He could use the credentials that's used on the CI/CD to access the Kubernetes cluster.
Right.
And now there is a clear separation. He push code, and another agent, which is, for example, Argo CD or Flux, will grab it and deploy it. So it's not possible anymore for a developer to use that credentials directly. He will have to go through Argo CD and leave traces, leave logs, and so I think it's a very good product. Another good thing about Argo CD, it's if you allow developers to access the Argo CD interface, they will be able to see what's happening on the Kubernetes cluster, see the pods, and they don't need any more CLI access. They can just use Argo CD to see what's happening. So it makes their life easier, and it's more secure at the same time.
Well, you eliminate the risk of someone typoing something and accidentally, having the permissions to delete something that they shouldn't be able to delete, or so many different scenarios you could just eliminate that way.
Yeah, of course. It causes other security threats because if you don't configure Argo CD properly, it's always the game of cat and mouse. Each time you add another layer of security, you will create a new way to breach it, basically. And I think that's it. If you already do airbag namespaces, and if you have some kind of policy engine to protect, normally nothing wrong can happen. Nonetheless, there are some typical cases where you have to still be careful about things. For example, the API server, lots of companies keep it publicly accessible and just rely on airbag for security. If you handle sensitive information, or if you have some security concerns, restricting the network access to API server would be a very good thing.
That's one of the other questions we have, actually, is that always is it always an absolute requirement? And one of the things we recently had a few friends from Solo.io come on and talk about API gateways and that as obviously a quality of life thing, but also a security measure. So if you were going to restrict access to your API server, how far should you do that, and how would you go about doing that?
So the first step is just leaving it public, but maybe it's because I'm security specialist, I really don't like that. So there are
that scares me too, yeah.
Because, for example, there could be a critical vulnerability on Kubernetes. It happened 5 years ago, and everybody who had his API server public could be hacked and couldn't know about it because it didn't leave any traces in the logs. So this is one of the cases why you should absolutely do some network restriction on the API server. Another use case is you do something by mistake and you open your API server, like I told before. So I'm not a VPN fan. Maybe it's complicated to set up on computers. There are some different measures you can have. For example, the first thing is just IP whitelisting. You just do IP whitelisting. You can use a Bayesian host in front of, so developers can rebound on the Bayesian host to access the API server. You can use a VPN just for everybody to have the same outgoing IP address, and you whitelist only that address. Maybe that would be a good use of the VPN. or you can use more advanced systems like HashiCorp Boundary. It's the person's based host. It's honestly, I think it's very, it's a very good product. And
So let's talk about there's two things that came out of that. I'd like to talk about Boundary in a moment, but thinking about VPNs, as you said, they have their place. Maybe you don't have to be the biggest fan or whatever, right? I think we've all spent a lot of years dealing with a lot of crappy VPN, right? So, and I understand the pain of that, but uh, you know, WireGuard's an interesting thing as a set of as a protocol set, right? And there's a lot of interesting projects that are coming out that have WireGuard implementations and whatnot. Tailscale, for example, is a really popular one. I think Tailscale is a lot of fun, and I've seen in a lot of the hobbyist hacker groups that I'm a part of, people are just straight up ditching all of their weird homemade solutions and weird like running on a Pi somewhere, blah blah blah, and just going, or just letting Tailscale handle it. Like, is that a path forward for more than just hobbyists? Is that something that like a business could be like, you know what, we're actually going to be leveraging this as a mechanism for controlling, for gating access from the public internet into our control plane, for example?
so, what's your question exactly?
My question is if we're going to talk about VPNs, and if we're going to use VPNs at all, would something based on WireGuard, something like Tailscale, be trustable, or should we still be using completely self-contained, corporate level VPN stuff that we're rolling our own?
Honestly, I would use this kind of products. I would trust them to do the job, which is just preventing some random attackers to find your assets publicly available using Shodan or tools like that.
Mm-hmm.
It's always a matter of how paranoid you are regarding security.
Fair enough.
And
I suppose if your threat model includes somebody targeting you specifically, then you'd have reason to go for something more heavy duty. But if what you're protecting against is people just randomly, pinging various endpoints and hoping to get something out, then you've deterred them at least, and you've established that you're not an easy target.
yes, of course.
I remember the show my age here, but the very first Monitorama that was held, many moons ago now. I think it was in Boston, if I recall correctly. And one of the talks was basically on, on threat modeling and actors. How do you define actors when you're talking about threat modeling? And the title of the talk was, "There are only two models, Mossad and not Mossad." Right? Basically, sort of a tongue-in-cheek way of saying, like, either you're being specifically targeted by a high-powered state-level actor, or you're not. Right? And like, figure out which one it is, and that's your response.
Yeah, it's a good way of seeing things, I think, yes. Most of the time, attackers will find low-hanging fruit on the internet. They don't want to target you specifically. And if they start targeting you, the first thing they will do is try to find everything that you have publicly reachable on the internet. So you don't need a super product to do protection of your attack surface. I think most of the time we just deploy a virtual instance with SSH and create the custom scripts for developers to access API servers or databases. And it works until you have more than 50 developers. It's really cheap. A Bayesian host can do the job easily. So you always have to adapt to the size of your team, how it gets complicated to manage it. When do you start using more corporate solutions that can scale easier? That's a question.
One of the things that struck me about some of the things we've mentioned or that you've brought up so far, like Argos DD and protecting your API server from public access, those aren't restricted. They're actually making developers' lives easier. They're
Yes.
not introducing friction to the developer's life, which is sometimes people frame security that way as something that's going to make it harder to do your job as a developer, but in practice, I think that's not actually true very often.
It's my everyday job to make people believe that security can not be something painful and boring, and trying to find tricky solution for them to have an easy life without compromising the security. And I think during the 30 past years, security has always been a pain, and there was a segregation between security teams and developers, like we used to have before DevOps, between developers and administrators. So we are trying to merge that. And for example, as a SecOps engineer, I always counsel to use Argo CD or things like that, because they have a security value, but it's not a security product. It's just a good architecture, good implementation. And whenever you do something that developers hate, it means that you have not done it well. You should find another solution to do that.
Yeah, I mean, personally, from my perspective, knowing that I have been prevented by security policies, and it's actually very difficult for me to do something wrong that's going to compromise the project I'm working on. That's really reassuring. Yeah, there's that peace of mind for developers that actually they can do their jobs more easily without fear of something bad happening because of that. I mean,
Yes.
I've deleted an entire code base before, not being able to do that because I simply didn't have the permissions. Is that's a good thing, and it's a good thing for the
Yes.
peace of mind of your developers.
Well,
It's good to be
it's the idea of having
independent.
guardrails, right? Like the
Exactly.
guardrails are there to make sure you don't plummet off the cliff.
Mm.
I mean, ideally, you're piloting the vehicle in such a way that you don't plummet off of the cliff. But if it's for some reason the vehicle is not being piloted in that fashion, maybe it's a good thing for the guardrails to be there.
Yes.
Right?
I want developers being able to run and jump and do everything they want, but behind guardrails. And the bad security engineer will say you have to walk because the floor can be slippery and it's dangerous. But no, do whatever you want, just don't fall out of the cliff. Yeah, exactly. And it's not only a matter of developers doing a mistake. Developers can have his account compromised, and if an entire company is hacked because of these developers having his computer hacked, the moral it can be how do you say it in English? A very bad mental experience for the developers to be responsible for that.
Yeah, I mean, compare like a junior developer having, typing the wrong command, and the system goes, "Oh no, you're not allowed to do that," and then the senior can walk over and say, "That's because that policy is there because if that command had gone through, there would have been these consequences." Compare that scenario to those consequences happening and that junior engineer being, hopefully, not like massively blamed for it, but I'd still feel awful, and
Yes.
like work to fix the mistake now doesn't have to happen because the mistake was not allowed to happen.
A lot of people, especially working in ops, traditional ops, right? Taking down prod is sort of a rite of passage, right? Everybody's done it at least once, type of a deal. And we swap war stories, and we go, "Oh, it's not a big deal," and so on and so forth. But like depending on what prod is, maybe that is a big deal, right? Like, what if prod is the emergency response system in your neighborhood? What if prod is the thing that allows ambulances to be dispatched or fires to be detected, or the heartbeat of someone during surgery to be regulated?
The
right?
Therac 25. I mean, that's not prod necessarily, but
right.
engineering
prod
gone
could be like a little e-commerce site somewhere that goes down for 15 minutes, and like that's sad. Or prod could be something that's like a robot doing remote surgery. Right.
Yeah.
So there's different prods, and maybe it's bad if you can accidentally take it down.
Yeah, I mean, it comes
Yes.
back to that principle
Right.
where if a human mistake can cause that kind of, if your developers and your humans have to act perfectly for your system to keep running, that's a badly designed system because you cannot rely on perfection from people. And it's as true in security as it is anywhere else.
Well, you can't rely on perfection from computers either.
Oh, no, true.
To be clear, right? One, because they're coded by people, So there's that, you know what I mean? And two, because stuff happens, right? Like
Mm.
we like, oh, there's always like, oh, there's a cosmic ray and it flipped a bit. Like, don't be wrong, it's not like that happens very often, but it does happen.
Well, we just had a vulnerability reported that affected AMD processors, Zenbleed, and that was this
Zen bleed.
week. Yeah.
There you go.
And we at Scaleway have those processors, and we patched them. I think it was within about 3 hours or something.
Yeah, from disclosure to fully patched across prod was a question of hours. But
Yeah.
not to brag, but we did the thing. But
I
there
guess
you go.
for developers, I suppose the question is there anything you can do to protect against those kind of vulnerabilities?
Honestly, these are the most frightening vulnerabilities. It's so low level that you cannot do anything. It's like Meltdown or Spect. Some years ago, it was the same kind of vulnerability. Only this one, Zenbleed, seems to be exploitable remotely, so it's even more frightening.
Yeah.
And in that kind of case, you just have to patch as soon as possible. Unfortunately, it's so low level that every system you can build to detect intrusion or
It's going to miss that completely.
yeah, they are on top of the processor. So
Yeah, it's sort of a higher level of abstraction.
yes, exactly.
On that note, one of the questions we have is so Kubernetes has a lot of abstractions in it. So it's an incredibly complicated piece of machinery, and in order to operate it, we have to abstract some of that away from the people who operate it. Are there any of those abstractions that you think are very well done from a security point? Are there any that sort of it's really important to know about the underlying stuff in order to enact good security behaviors and good security policies?
I think Kubernetes made the things very well. The architecture is so simple with just an API server database to store objects and all the complexities behind the operators and the controllers who are running things. So it was very well designed. So I don't think you have to know the insights in a security perspective. There are some tricks to know, but it's more things to know, whereas things to understand how it's working. But
You're not
I
going
get
to shoot yourself in the foot by not having a deep understanding of the networking inside a cluster.
no, I don't think so.
That's really good.
Maybe
Nice. Yeah, we
it's
love it when abstractions are well designed. Yeah.
there are some things to know. For example, a pod should be able to communicate with any other pod. Normally, it's in the Kubernetes documentation, so you don't build something thinking, okay, nobody will come and access that service. Of course, other pod can do that. I was thinking about a good example, maybe. I don't know if it's really answering your question, but the design of Kubernetes makes that if someone has write access to the etcd database, so it's called a write primitive in security. You have a write primitive on some asset. It triggers an execution primitive on the Kubernetes cluster because you just manually write a specification of a pod in the etcd base, and a controller will automatically see it and deploy it on the cluster. So if you look on Shodan, the tool to scan the internet, you can see, I just checked earlier, you can see 4,000 etcd database reachable on the internet, maybe not anonymously reachable, but some of them obviously are. And you just get execution on the whole Kubernetes cluster through write primitive. So I think that's kind of interesting.
That sounds
Horrifying?
less than optimal. Let's go with. Yikes. Okay.
There's scope for improvement.
Yeah, room for improvement. Let's start, stop, continue. Let's
Stop.
stop putting
That.
etcd data with the right
Yes.
permissions on the public internet.
That
right?
could be one of the low-hanging fruits you asked me for.
Yeah, sure.
And another thing, it's not Kubernetes itself, but it's managed Kubernetes on the cloud. There are a lot of interaction between the cluster and the cloud environment. and I don't think most people know deeply about it, and it can be dangerous. If I take the example of EKS on AWS, it's the same with Google Cloud. But if you have an execution on a pod, for example, you are a hacker, you find a vulnerability, you get access to a pod. The way the nodes are joining the cluster in an automatic fashion create a vulnerability, because from the pod, you just request the metadata of the instance. So you request this weird IP address 169.256.169.256. You reach it, and you get the IAM role of the node.
Yeah.
You get the security, AWS security credentials of the node, so you can act as if you were the node itself. And from that, you can create a kube config, join the cluster, access all the secrets that are scheduled on the pod. So if you don't know that, you just pop your cluster. You think it's a managed cluster, so it's secure by default. And there are this kind of stuff you have to know about.
And so
Otherwise,
the threat model there is somebody gaining access to the pod.
yes. So
Yeah.
it's already bad enough, but
Yeah. But from there, it gets much, much worse very quickly.
yes, and it could be other less critical vulnerability, like a server-side request forgery. It's when you ask a server, you send an HTTP request, which makes the server send another HTTP request. So you make the server send another request, so you can ask the pod to send a request to the metadata and get access to the cluster through this kind of vulnerability. So it can happen.
Wow.
It's something that we see.
What could a user of those managed services do to mitigate that risk?
Sorry, can you repeat?
If I am a user of one of those managed services and I have a cluster there, is there anything I can do to mitigate that risk?
Yes. So, for example, AWS published a new way, a new mechanism when it makes it more difficult for a hacker to do it remotely. For example, the SSRF vulnerability I was talking about is not possible if you correctly set up the nodes as stated in the documentation. But if you have execution on a pod, the only things you can do is create network policies.
Right.
So it's a Kubernetes mechanism. You create a network policy. You prevent every pod to request the metadata of the node, and you're protected.
When do pods genuinely, like legitimately, need to access that data? Is there ever a case that then
Yes,
you
there are.
are restricting the pods from being able to do?
Yes, all the pods that are created by the cloud provider to handle, for example, the network stack, to mount disks for storage, all that kind of pods needs to access metadata. So you need to check beforehand, be careful, and just don't deploy the network policy globally. There are some pods that need it. Yes,
Right.
exactly. And it's the way the pods are getting access to AWS natively. For example, if you are on a pod and you just do AWS or GCP key command, the pod will try to get the credentials from the metadata. It's natively it will do it. So I've seen lots of companies who discovered that behavior, and to give access to pods, to databases or buckets or anything, they modified the role of the node, the IAM role of the node, and added a lot of privileges for the pod to use. But it's a very bad habit because of what I just said.
Yeah. I suppose the most sort of some of the hardest vulnerabilities to address, I suppose, are going to be ones where you can't programmatically determine if a need for access is legitimate or not, or a request for access is legitimate.
Based on the type of the pod, you should know these pods should use it, and all the applicative pods should not, for example. Yes.
Right.
So there has to
Scary.
be some. I mean, so that would then indicate that you have to go into it one, having this knowledge ahead of time, right? So that you can actually sort of organize your pods. You can, whatever you're gonna label them. You're gonna et cetera,
Put them in
right?
namespaces or something.
Exactly. However it is, you're gonna sort that out. But that's something that is intentional at deploy time, right? Like, you have to be walking into this knowing that this is a threat model and mitigating it out of the gate,
I would
right?
say that's one of the places
Yes.
where the abstraction perhaps is not, that abstraction has leaked, right? If you have to
Yes.
know about the differences in your pods in order to change their behaviors from a security standpoint, do
Yes,
it manually.
exactly. Yes.
Hey, maybe it'll be addressed in an upcoming Kubernetes update. You never know.
Well, I mean, this, yes, but at the same time, that's pretty specific to your environment, right?
Exactly. Yes.
Mm,
Yeah, it's not like Kubernetes as a platform, if we want to use
yeah.
that word.
Or as a mechanism, as a piece of machinery.
Yeah, as a yeah, right, has this idea of, oh, this is an application server and this is a X and this is a Y. Like, it's how you're using the thing,
Right.
right?
Yes, exactly.
Yeah.
In many places in the documentation, Kubernetes says we do it like this. You have to be responsible, and you have to add layers, components if you want to do something else. So it's a very general purpose thing, and each time it's implemented, you have to think about what are the consequences of that. And for example, the implementation the cloud providers have done have added a lot of things that are not easily reachable through the documentation. You have to dig into the cloud provider documentation to know how it's working, how a node is joining a cluster. It's different in each cloud provider. It's always a complicated process. Most of the time, it's not totally documented, so you have to find it by yourself, dig, create a pod, try to access the data. For example, in Azure, there is a token in the disk of the node, in the file system of the node. So if you have a vulnerability that allow you to access the disk instead of accessing the network, it's the same problem. But to know that, we had to try to create the clusters and to try to hack it, basically to find this kind of implementation problems.
Things to be aware of if you are choosing a managed Kubernetes provider.
Absolutely. So I want to follow up on that. I'm furiously trying to live tweet as we go here, but I did want to follow up on that. So one of the great promises of containers, and one of the great promises of Kubernetes, and one of the great promises of all these things, right, is that it's, oh, no way, you just write some YAML and then you can run it anywhere, right? And for those of us who've actually run any type of infrastructure ever, we
It's
know
not
how
that
much
simple.
of a dirty lie that is, right? But I mean, as I'm coming at it from a sort of a DevOps perspective, right? Platform engineering, SRE, whatever we're calling ourselves now, and uh, I'm thinking to myself at a very simple level, which is just like, how my app in this container behaves on this particular provider is going to be different from this exactly the same thing. The performance profile is going to be different elsewhere, and like, my network profile over here is not going to be the same as my network profile over there. But you're saying, in fact, it goes even deeper than that. It goes into literally how that service, it's in some cases hidden, opaque opinions about how things should be deployed and how things are communicating at layers underneath things that are even visible to you as a user of that service, actually
Yes.
have ramifications on how you have to configure and deploy your services.
Yes, exactly. I think it became more and more complicated. We added layers of abstraction, of so-called simplification, and maybe it makes it easier for the end user. I'm a developer. I create a container. I run it. It's simple, but when you operate the infrastructure, you have to know every layer. You have to understand what's going on deeper. For example, the network layers in Kubernetes can be tricky.
Hmm.
Um, and yet, I think it's kind of a false promise. Is each time you add a layer, you make things simple for someone, but someone will have to pay the price of it and have to understand it fully to be able to operate it. Yes.
Yeah, if it was genuinely that simple, it's what we would have done in the first place, you know?
Sometimes people create a Kubernetes clusters and do lots of complicated things just to host a simple web page. Or sometimes I think it's funny because they don't know how to do it manually. It's so much simpler to do it that way. So it's kind of ironic sometimes the way IT is going. I think how will it be possible for someone in 100 years to be able to understand why we have made all these choices and understand from the beginning, from processors, from assembly language, how is it really working now?
When you forget 100 years, let's talk about 100 days.
Yeah.
I mean, I've walked away from code bases to go on vacation and come back and been like, how did any of this work? You know? So I think 100 years, that's extremely optimistic, dude.
I mean, one of my favorite talks that I do is about memory management in Python and weird behaviors that arise in CPython due to the underlying mechanisms that it's using for memory management. And you see this again and again. It might not be necessary to know these things, but having that context allows you to make better informed choices. And sometimes those choices have security or performance or usability ramifications.
Yes, exactly. Yes. In the days we had to handle memory to create variables, and now developers don't think of that. And sometimes you have website, the JavaScript content it's 100 megabytes and it's totally useless. And yeah, but maybe it will improve with the time. We will find a new complicated layer to add to remove all the unused code, for example, or I don't know.
Once again, just madly live tweeting. There's an internet personality that I followed for a long time on the bird site, which is no longer a bird, and I'm now following on Mastodon, whose nom de guerre is Foon, Foone. Foon is one of the legion of sort of digital archivists, archaeologists, sort of the Indiana Jones, I guess, of spelunking and old hardware.
I love her.
Right?
Every time I see her channel, she's doing something like her Mastodon or her Twitter. She's doing something new and bizarre.
Yeah,
And
right. It's all over the place.
reverse engineering old Wii game engines to do various bizarre things. I love it. I love
Yeah,
it.
it's out of control stuff. And you mentioned this sort of hard for people in 100 years to understand technology decisions we made today. And this is very much like kind of in that zone where Foon's sitting down and being like, okay, we're going to pick apart this video game. Like, this is a video game for some old platform that existed some time ago, right? Like, I probably played it as a teenager or as a child or something, right? And they'll go, okay, well, like, let's start pulling this apart. And what they discover inside there is that it's actually like running an emulator for a completely different platform. That they sat down and like wrote an entire emulator for a completely different hardware platform.
I forget
right?
which game it was recently that Foon found that game contained within the files, completely unused on the target operating system, the Windows runnable version of that game.
Yes. Stuff like that happens all the time, right? And like without context, it's, imagine, and this is stuff that happened within living memory. Like, we can still go and track down the people who wrote this stuff and ask them questions. And sometimes that happens, right? They'll chime in and be like, yeah, I wrote that, and this is why we did it. You know what I mean? But imagine 100 years from now. Imagine 100 years from now, right? We're digging through the ruins of civilization and we find a pristine SSD, right? And we take it to the laboratory and in sealed conditions, right? In some sort of vacuum, we've got our suit on.
If it's an SSD, it will be unreadable by then because
we plug it in.
in.
No, just imagine, right?
Yep.
And we plug it in, and we've got like Foon's brain in a box somewhere, and
Yep.
they're like using a robot, right? And they pick this thing open, and they'll be like, "What the fuck is YAML?"
Well, that's one of the things of like data durability is one thing is, again, the SSD wouldn't survive that long because MOSFETs leak charge, blah blah blah. But like, let's say that we had a physical medium that data survived in. But the other part is that the knowledge to interpret whatever's stored there I have a talk on this. I gave it a few days ago at EuroPython, and we've got manuscripts we can't read in languages that have been lost, and yeah, with technology moving as fast as it does, context for why decisions are made might have been lost, and if you don't understand them, it's the Chesterton's fence thing. How can you know whether or not it was a good decision and you should build on top of it, or pick it apart and build something else?
Yeah, that's exactly it. And it affects us in all sorts of weird places. I don't know if you remember, this is getting a little old in the tooth now, but like PDFs, right? PDFs, like everybody's like, oh, it's a PDF. Like everybody knows what a PDF is. Everything can read a PDF. Well, sort of, right? Because like everything that reads a PDF now couldn't necessarily read a PDF that got originally written 10, 15, 20 years ago. Like the specification for PDF, which seems immutable, right? It seems like it's anchored. It seems like this is one of those ancient things. You know what I mean? But like if you've still got a box of floppies in your closet, I may still have boxes of floppies in my closet, assuming any of them are still readable. Like
magnetic tape is pretty durable, or magnetic.
You know, what are the chances that I can plug one of those in and even get data off of it to even start making determinations about whether whatever that data was a good idea or not?
You'll be able to get the binary out, whether or not you'll be able to parse that binary.
Right?
Yeah, it depends on, I think we have to create real long-term protocols and way to do things. For example, IP addresses, the Ethernet protocol, it's been going on 50 years, and it is still what we use. Maybe PDF is not a good format for storing files, or maybe it's too complicated to write it simply. But
yeah, I mean, and thinking about the PDF and going in the other direction, you can have specifications that are purely additive, so that you don't end up with you still maintain backwards compatibility, right? And then you end up with something like CSS, which is overwhelming to learn now as a beginner, because there's lots of different ways to do the same thing, because they've retained old ways that might not be as usable because they need to maintain backwards compatibility. A key part of the CSS spec is that it's additive. We've very much got off the topic of Kubernetes security here.
Yes.
But I think it's true that like it's not just the decisions we make, but why we make them is a huge part of the value of them, and that's going to be part of like training your developers about like, why do we do these security behaviors?
And to go back to Kubernetes, they decided to create a simple specification, always saying why they did it and why they don't want to make things more complicated, why you have to implement your own authentication users and password process, because they don't want to do that. Maybe in 5 years, it will be a completely different way. So they created this minimum product where everyone can plug on it, and the plugs will evolve, the tools will evolve, but Kubernetes itself, it should last a very long time because it's been designed for that.
It's interesting because there are already platforms, projects, and so on and so forth that are basically kind of identifying a core problem, and I put problem into quotes here, have declared there to be a problem, which is that Kubernetes is too complicated. Okay, we can have a debate and a long talk and blah, blah, blah about whether that statement is true or not. But the people behind these projects assert that it is, and they go, we are going to come up with something else. Right? So we're gonna go back to first principles, and we're gonna do the thing, and we're gonna roll forward with that. And I've seen a number of these projects come and go over a couple of years now at this point, right? Where they go, it's so simple, it's so straightforward, and it gets much ballyhoo on GitHub, and it gets posted to the orange site, and so on and so forth. And then as the project rolls forward, they realize, well, what about this case? Well, what about that case? What about this feature? Or what about that functionality? And then you're about 5-7% of the way to implementing Kubernetes
all over again.
And then the project just kind of goes, right? Like, down this way lies madness.
One of our first episodes of sessions, I think we came up with the joke that, like, human civilization starts with fire and ends with Kubernetes. Like, that's the end, that's the stable state, that you'll always end up re-implementing Kubernetes.
Yeah, I like that play on the joke. It starts with fire and ends with fire, right? But it starts with fire and ends with Kubernetes, which I don't know which of those two is more apocalyptic. I have to be honest with you.
I mean, I think it's a Kelsey Hightower analogy of Kubernetes being like a 737 or something, like a big aeroplane. You don't always need that, but if you do, this is the way to do it.
Exactly. Yes.
Yeah,
We
that's
we have we
okay.
have many clients that they don't want to go with Kubernetes because they are afraid of the complexity of it. But the things they will do if they don't use Kubernetes to achieve what they want to do will be much more complicated. They just have built it themselves. So we say no, go for Kubernetes, learn it, and you will
It
gain
it
lots of
reminds me
time.
of the analogy of like it's Mossad or not Mossad. Like either you know you won't ever need Kubernetes, or maybe you might, and you might as well use it for the reasons that you've just said. Because like my personal website, which is going to be just like a little Django deployment with a bunch of static files and like a couple of models and forms and things, I don't need Kubernetes for that. But if I'm suddenly I'm writing like, I don't know, a front end for a big logistics company or something that, people are going to keep track of things moving around, maybe I might, maybe, and future proofing that is, if you know you're going to have the kind of problems that Kubernetes addresses, maybe you should be using Kubernetes.
You just have to be not. Lots of people say go for Kubernetes whenever, but it's not a good idea. I don't remember this product. Maybe you know it, where you can define inside the Kubernetes cluster resources for cloud providers. You can even create other Kubernetes clusters and use the Kubernetes mechanism to handle the state of life of these resources.
No, I don't know that. Yeah.
So you can create, for example, a CRD for a whole infrastructure, and you create it, and this project, I don't remember its name, it will contact the API of the cloud and create the network, create everything, even create a Kubernetes clusters, and you will handle the life cycle of your whole infrastructure as a Kubernetes resource.
Wow. It's Kubernetes all the way down.
Yeah, I was about to
Yes,
say that's some Inception stuff right there, right? Like,
exactly.
it does remind me. There was it made the rounds on the intertubes a little while back, which was like running Kubernetes inside of Kubernetes, and the which is not weird. Like, you can do that. It's not necessarily a great idea, but the game was basically like, how many layers deep can you go before the system becomes unusable, right? Where like the overhead of running Kubernetes consumes 100% of the resources of the machines upon which Kubernetes is running. Right?
You end up like running lighter and lighter weight distributions as the further down you go, and
Yeah.
amazing.
Yeah.
I found the name of the technology. It's called crossplane. Crossplane.
Ah,
It's kind of crazy. I think sometimes you can have really good use case for that. For example, we had a client. He had over 10,000 GCP projects, and he needed to create Kubernetes clusters, databases, um, GitHub projects, GitHub groups, everything for thousands of employees. So we use Crossplane to do that. Whenever there is a new team, we push a button and it creates the CI/CD, the GitHub project, the Kubernetes clusters, the databases, everything. So it can be cool, but
that is very cool. Yeah.
whenever you talk to someone about Crossplane, say you go too far. Please stop.
It's like meta classes in Python. If you need it, you know you need it. If you don't know if you need it, you probably don't need it. Yeah. Conversation that we've just been having, I'm sort of going, actually, it doesn't necessarily sound any harder than anything else. Yeah, as you say, it's like the problems that you will bring upon yourself by trying to do good security in this whatever kind of
When you create this kind of custom systems, and
yeah. And I mean, again, one of the things that, though, you've deployed your thing with Kubernetes, and there's a golden paths for doing good security. Somebody can onboard onto your team and learn those and use prior experience they may have, and it will still be applicable, which will not at all be true of a big custom Frankenstein deployment. That's all internal sort of institutional knowledge. Whereas because Kubernetes has this thriving community, you're bolstered against that somewhat.
and You talk about securing a Kubernetes cluster, but I think through Kubernetes you can do lots of secure things that you couldn't do otherwise. For example, if you take the example of ephemeral environments, it's a hot topic. Lots of people want to, as a developers team, to be able to bring a whole environment to test their feature. With Kubernetes, it's super simple and it can be super secure. For example, we had this project where we use Kyverno, the tool I was talking about for policies. It has some mutation policies too. So we give the CI/CD only the right to create a namespace in Kubernetes. And when the namespace is created, Kyverno is detecting that and creating a cluster role, allowing admin access to this new namespace. So it's very simple, very easy, and it will be very difficult to achieve that without Kubernetes. I think be able to create this kind of environment without any rights, basically.
I mean, you may as well take advantage of all of the work of the incredibly clever people who are behind all of these CNCF products and projects. Why reinvent the wheel?
Yeah,
I'm very lazy. I don't want to have to do that. I'd much rather somebody else has done it for me and open sourced it.
Yeah, I love CNCF projects. Each time they are bringing new projects, I'm like a kid. I'm going down and the last one I saw was it's called Paralus, Paralus. It it seems to be very nice. It's for just-in-time access to Kubernetes, so you can handle your role, your users, your group with that through your SSO, and give a way for a developer to ask for an access and get it instantly. And it seems really nice. And CNCF is always bringing projects like that, so that's cool.
And I mean, I'm from a security perspective, like I'm a big fan of SSO because you centralize all of that stuff and then you only have one point where you have to manage it all. I like that. So
Yeah,
things like the OIDC plugin for Kubernetes, for example.
yes. For example, giving access for your CI/CD runners to access Kubernetes, or to from Kubernetes to access the cloud resources. It's very clean. But talking about SSO, sometimes it's difficult to really achieve plugging everything to SSO. You can have, for example, open source projects that you have to pay if you want to plug the SSO, or you have custom application that does not support OIDC. And I think it's a very interesting subject in security. In Kubernetes, we use OAuth 2 proxy. I don't know if you know that component, OAuth 2, OAuth
Yes.
2 proxy. And you can pop it as a pod and put all your application behind and use it to implement the IDC for your application. So
And also with permissions, because OAuth obviously is not, OIDC is the identity layer on top, but OAuth is actually really fully featured for that kind of thing, intended
yes.
for it. Yeah. Awesome.
All right, so we are at time.
Oh my gosh, yeah, that went so
It
quickly.
went so fast. Oh my gosh, are you kidding me? I've got my little timer and it starts blinking when we're at a minute out. Yeah, and I'm like, I didn't even realize. I was like, oh my god. So we are at time, and of course I want to be respectful of everybody's time, of our time, of time of our audience as well. It's Friday afternoon in our collective time zone. Maybe not for you. Maybe if you're watching on a replay, it's the middle of the night. Whatever's working for you, please
Well,
continue to do it.
Thibault shared with me that this is normally his day off.
Oh my
So not
god,
only has he been gracious enough to spend his time with us, but his free time with
his
us.
free time. Oh my
So
goodness. Oh my
yeah,
goodness.
an
Well, Thibault,
enormous
you know
thank
what?
you.
We are not necessarily that far from one another. Let me know if I can take you out for a beverage of your choice sometime to say thank you for spending a little bit of your time with us on your day off. Super appreciate it. I would super appreciate you out on the internet sending us your questions, interacting with us, sending us theme ideas, topic ideas, guests you'd like to see on the show. We do integrate that. That 100% drives us on the Scaleway sessions. So thank you so much. And thank you, Thibault, again for coming on and
Thank you
taking the
very much.
plunge. Yeah, we really, really, really appreciate it. We'd love to have you come back
And thanks you for that. I will use it probably sometime.
Yeah, exactly. You know what you could do is next time there's some sort of security incident, you could like head
Take your
down to the data
stethoscope.
center and see if you can hear the bugs, right?
You go
Excellent.
in there already knowing the solution, and then you listen
Yeah,
to
you
it,
just
and then you
listen
just
to it, be like,
and then you say as if you've managed to learn it from doing that. Yeah.
yeah, exactly. That would be a good social media moment for you. So, what do we got coming up this summer? It's the summertime here in Europe, kind of where we are, and especially as we roll into August. August, for those of us here in France, is a time of rest
Hmm.
and a time of relaxation. We hope that it will also be a time of rest and relaxation for you, if that is appropriate for where you are. Well, we are going to continue to have Scaleway sessions throughout the course of the month. I can't guarantee you that they all are going to be live, but we are going to continue to have them. So feel free to spend your Friday afternoons with us through the remainder of the month. And then as we roll into September and the start of the next sort of post-summer period, be happy to have, again, your suggestions for show ideas and guest ideas. Until then, we'll see you out there. Stay safe, everybody. Bye-bye.